Hi, so my name is Jack Christensen. I'm a senior developer at Hashrocket. We're a web consultancy. We do mostly Rails, but a fair amount of Android, iOS, a little bit of Elixir, Clojure. I've been doing Rails since the pre-1.0 days, so it's getting on to be about 10 years now. And I'm hoping some of the things I've learned will help you all. So when we say web scale, what do we mean? It's kind of one of those buzzwords that means whatever the person trying to sell you something thinks it means. So for the sake of this talk, we're going to define it a little bit. Maybe it means number of users. So Facebook has 1.7 billion monthly users. I would say that's web scale. How about requests per second? Google does not publish their numbers, but the estimates I've read say that just search is 63,000 per second. So I'd say that's web scale. That's really big. How about big data? Google, again, their total storage, YouTube, Gmail, all the search indexes. Again, an estimate is in the exabyte scale, which I don't even know how to comprehend that big a number. What about some other measures of scale? So how many things does a system do? How many applications are there? Lines of code even. The number of languages, frameworks, libraries, number of developers or teams. That's an important one. These are areas where non-web scale may even be bigger than your traditional web scale things. Think about an insurance company or a bank company, all the internal systems, they have all the processes. For purposes of this talk, we're going to say web scale is when the system obviously cannot run on a single node or a traditional n-tier architecture. So for this sake, we're saying if you have n web servers in front of a relational database, that's still a traditional architecture. That's not web scale. Another criteria is server are cattle. They're not pets. You don't have names for them. If something goes wrong, you just delete the VM and create a new one. And you don't think in terms of servers, you think in terms of services. So where does this talk apply on that scale? Well, we're definitely talking non-web scale. And we're going to focus to some degree on small dev teams. So some of the suggestions I'm going to give and experiences I'll share are totally wrong if you're working at a larger scale. If you're working on a team with 1,000 people, if you're working at 50,000 requests per second, a lot of these things just are not applicable. So with that caveat, let's talk about something that actually does kind of have some applicability across all sizes. And that's how do we get more done? Well, the big problem is our minds are very small compared to the problems we have to deal with. We have to think about a lot of things at once. And anything we can do to think about less things at a time is usually a win. An interesting little turn in that is kinds of things versus number of things. Kinds of things are a lot more expensive. We'll talk about that a bit in detail. So what are some of the things that we want to minimize? Well, how about data stores? That's probably the most important one. When you have multiple data stores, you end up with all sorts of interesting problems of consistency and syncing. Frameworks, Rails is a big framework. It does take a while to learn. We're really productive in it, but it's not something you learn overnight. Languages, a language like Ruby takes a while to learn all the dark corners. Libraries even. One problem I've seen in a lot of systems is you start with something a little old, or you start with something new at the time, but it gets a little old, and we want to use the new hotness. For example, we don't want to use test unit anymore. RSpec is the thing. Now, I guess if you're not newer than 5 years or so, you might have never even used test unit, but that used to be the thing a long time ago. So you end up with a project that you have a bunch of test unit, but people want to use RSpec, so they add RSpec, but they don't take out the test unit. So now you have two entire systems to maintain. I've seen it as bad as 4 or 5 different test suites. You got test unit, you got RSpec, you got shoulda, you got coulda, you got cucumber. That's not where you want to be. So just as a general rule, you want to minimize number of things and kinds of things. But that could be a little constraining. You know, a good developer is curious. We want to learn new things. You know, the pragmatic programmer recommended that you learn a new language each year. That's a good idea. But it's also not right to do, you know, resume-driven development. You know, what's the latest thing I saw on Hacker News? Well, better find a way to make my employer pay for that for a little while. It's not really ethical. But by the same token, a good employer wants the type developer that is curious and wants to learn new things. So what's a solution for that? Solution is experimental projects, internal tools, open source time. That's something we do at Hashrocket. We have Friday afternoons where we can work on open source tooling, we can work on documentation, just any sort of learning, personal development, obviously open source contributions. And that's a great way to avoid the trap of just building in whatever the new hotness is into whatever system you happen to be working on, but still getting to learn and experience the new things and find out whether they work or not in production. So what's another way that we minimize the number and kind of things we have to deal with? Well, that'd be abstractions. So the right abstraction minimizes the number of things you have to think about and understand. So a leaky abstraction, that's another concept. It means you have to think about multiple things at once. So let's have a couple examples. Good abstraction, the file system. You very rarely have to understand what's happening under that abstraction. You know, hard pressed to think of any time as a developer that I've had to deal with sectors and cylinders and all the crazy stuff underneath. Now, an abstraction like Active Record, I totally have had to deal with SQL a lot, and the relational database underneath a lot. So the Active Record abstraction is very leaky. Now, that doesn't mean it's not useful. You know, with Active Record, you need to know Active Record and you need to know SQL. So you need to know two types of things. But in exchange, you have to write a lot less SQL. So your total number of things goes down. That's good. Another couple abstractions are the collector iterator concept. Depending on how you use it, that's either perfectly, you know, not leaky, or you use the wrong collection and you have a mysterious performance problem that you need to dive in and figure out. One of the worst leaky abstractions is RPC, remote procedure calls. You know, you call a method, you normally think, you know, I run a method, I get a response, but you don't know there's now a network dependency on a method call. That's usually really tough. So you should weigh the value provided by abstractions, you know, how much less stuff do they let you think about versus the cost. A general rule of thumb here is it's better to have a little too little abstraction than a little too much. I think of the analogy of if you're trying to do something with too much abstraction, it's like trying to play the violin with boxing gloves on. It doesn't work too well. I seem to have lost my slides. Hey, yeah. So here's another way that you can think about less things at a time. And that's to store your code in a single repo. So once you get past, you know, your Rails monolith, or even if you still have your monolith, you're probably going to have a lot of other things that go with it. You know, you might have a JavaScript front end. If you're using React or Ember, it's quite possibly you're using, you know, Webpack or, you know, whatever JavaScript build tool, and it's an entirely separate project. If you have an iOS or Android client, those are certainly separate projects. You know, maybe background workers, miscellaneous scripts. You might be tempted to put those all in separate repos, and that's usually what I've seen. But that can be expensive to deal with. You know, you implement a new feature, that feature has to be implemented in all those repos. You know, it's you need to put it on the back end, you need to do the HTML front end, and it needs to go to all the mobile clients. So that can be a little weird when, okay, implemented this feature, there's multiple different pull requests on different projects. How do we sync all these things up? It's kind of hard. So a rule of thumb is if a single person has to commit to multiple repos for a single feature, it really should just be a single repo. Also a rule of thumb, if multiple people have to commit to multiple repos, it probably should be a single one. That's a little more understandable there if you have entirely separate teams. But if it's a single feature, it still makes sense to put it in a single repo. At its extreme, some organizations use a monorepo for the entire organization. I don't know if I'd go that far, but it works for some people. So getting toward the narrower focus of web scale stuff, or not web scale, who do we learn from? Well, I like learning from big, successful, companies, people, whatever, somebody who's done something. Well, Google's successful, Facebook's successful, Amazon, Twitter, Netflix. So we learn from the big, successful people and companies. We also learn from kind of just the distilled best practices that tend to filter down from them. So what have we learned? So we've learned to scale horizontally. We'll use distributed systems. Horizontal scaling means you increase capacity by adding the number of servers. To scale horizontally, that generally means you have to use a shared nothing architecture. And you, for redundancy and reliability, you go for the tack of not putting all your eggs in one basket versus the old idea of having a really secure basket. Now here's the problem. We're not Google. As we talked about the scale at the beginning, I would be shocked if anyone here is currently working on anything approaching to Google scale. If you are, I'd love to talk to you. I'd like to hear about that. But most developers are not working at that scale on a daily basis. Their production environments are huge. Their development staff, 10, 20,000 is huge. They have vastly different problems than most developers working in Rails do. So if we wholesale borrow their solutions, they can become our problems. So what's an alternative? So we could go back to what we used to do a long time ago. We do centralized stuff and we do vertical scaling. Now that has problems of its own, but let's look at it for a minute. So in vertical scaling, that means you increase capacity by having a more powerful server or servers. It's not strictly speaking a single node, but generally it is. Or you increase capacity by optimizing your code. Now this leads to a much simpler architecture, but the problem is eventually you run into a hard ceiling. At some point you buy the biggest server there is and they don't make any bigger. At some point you optimize the code as best it can be done and you can't go any further. At that point you've hit a hard ceiling that you just can't get around vertical scaling. Question is, how high is that ceiling? So it's smaller than web scale, of course. It's smaller. It's always going to be lower than horizontal scaling. But it can be a little bigger than you might think. So Dan Kegel wrote a post. Some of you may have read it. It was back in 1999. It was called the C10K problem, or 10,000 simultaneous connections. It's actually still an interesting read. It's been updated a few times through the years. But he discussed what do we have to do to serve 10,000 concurrent connections. And he talked about a lot of things that are commonplace today, like event-driven architectures like Node does or Nginx does, as opposed to the thread or process per connection that Apache was doing at the time. And a number of other different strategies. But the interesting thing was it was within sight then. Some people were maybe kind of doing it with idle connections if they really, stretched. It was definitely within sight, and it's definitely been achieved, a few years after that. The thing is, at that time, a Pentium 3 was a high-end CPU. Again, this is 17 years ago. So what's happened since 1999? Well, hardware is a lot better than it used to be. So you can just go to AWS. You can get a VM with 100 gig of RAM, 20-plus virtual cores, and it's less than $1,000 a month. What if that's not enough? Well, you go up to about $3,000 a month, and you can get 128 virtual cores and almost 2 terabytes of RAM. That's not enough. You can even just purchase a server, and you can get up to 6 terabytes of RAM. Now, you're looking probably at the 100K realm there. You're getting into the realm of call for pricing, not just buy this off the shelf. But it's still a possibility. Not necessarily a good one, but that's what our theoretical limits basically are for vertical scaling. How far can you go on a single computer? So most applications are not social media. They're not messaging. They're not big data. They're not something that's really going to go viral. In some sense, we still do a lot of the things we used to do. We build a custom storefront. Something off the shelf just won't work for this particular business, so we have to build something new. And then what goes along with basically every web application? Well, half of a CMS has to be built along with it. Those type problems are still more or less the same. we end up with a little more resource-intensive stuff because you're using, Web 2.0, you're using Ajax, all that sort of stuff, maybe some WebSockets. It's real-time updating. So maybe it takes 2, 3, 4 times as much resources as it did before, but not orders of magnitude. Server performance has increased vastly beyond that. So just as a thought experiment, maybe we should be more likely to use vertical scaling than we used to do. That was the commonplace thing, back in 1999. Now it's less common. But the reasons behind it have actually gotten perhaps more favorable in some ways. So with that in mind, let's look at some of the things we can minimize. Back to that overall theme of our minds are really small and we want to think about as few things as we can. So the data store is both the thing that's most likely to run into a vertical scaling limit, and it's the hardest thing to scale horizontally. Distributed shared state is really, really hard. That's the reason why Rails by default is a shared nothing architecture. But there always is something in back, or it generally is, that is shared. Your database, Redis, whatever data store you're using. So if we need to distribute things, distributed data stores have serious costs. So you can use specialized things, and they'll give you better performance and features, but it comes at a cost. So what are these costs? Well, generally, if you're using a distributed data store, atomicity, consistency, and referential integrity go out the window. Because also with distributed, you generally care about availability. We had that good lightning talk yesterday about the CAP theorem. It's pick 2. There's no way to have 3. If you're not familiar with the terms atomicity, consistency, and referential integrity, we don't have time to really go into it, but I recommend you look into it because you're missing some really great stuff. And if you're using Postgres, they're things that you can get very cheaply or for free. Distributed data stores also, and even just specialized data stores, I would consider if you have Postgres and you have a Redis caching layer in front, you're actually using distributed data. You have one authoritative source, you have one caching source. Remember, caching is one of the 2 famously hard problems. You increase your overhead quite a bit. You now have 2 things to deploy. You now have 2 things to back up. You now have a more interesting developer setup. Isn't it nice when you go on a new project, git clone, bundle install, rake DB setup, rake spec, and it just all runs? Yeah, it never happened to me either. But it especially doesn't happen when instead of it being just a single database, it's, oh, well, we got Postgres. Now, we also have this thing that's connected to MySQL. And the better set up Redis. Now, we're using Elasticsearch as our indexing solution. And somebody threw Mongo in there a few years ago when it was the new hotness. And then we just kind of were using it for this one thing. But we still need it. That type of stuff is really hard. It makes development setup, bringing a new developer on board really hard. It makes test setup really hard. Even just setting up your fixtures or factories becomes a lot more challenging. And I have a rule of thumb that I try and go by, and that's if it's too hard, I'm doing it wrong. Now, knowing hard isn't the problem. It's the too hard that's the problem. So I consider most of these things when you have multiple and specialized distributed data stores, I consider that too hard. Remember, we could buy a server that has 6 terabytes. That means that most, I would say, of the projects that everyone here works in, their entire data set could easily fit in RAM. This actually is not big data. A couple terabytes even, that is not big data. So what's our solution? Well, Postgres is a lot of a solution. So you can scale horizontally with read replicas. Writes are more difficult. That's actually generally the biggest problem with distributed any shared data store is writes, at least ones that maintain consistency. But you can easily get 10,000 plus writes a second on good hardware. And it can go substantially past that if you're willing to dive in and optimize. If that doesn't work, sharding is a next best solution. At least at that point, you have multiple of the same kind. You're not introducing multiple kinds of things. But it goes beyond that. So in lots of cases, we need like a job queue running in the background. Somebody signed up, send the email in the background. That's great. Well, Postgres has built in something called listen notify, which is basically PubSub. Now, it's not super high volume. There's no way it'll compete with, say, RabbitMQ on performance at high volume. But if you need to do less than a few thousand per second, consider just tacking it onto your existing Postgres implementation. Especially like for jobs, I believe it's a Q Classic, uses Postgres as the active job backend. It's definitely something to look into. Full text search. This is another one. Is it as featureful as Elasticsearch? Absolutely not. Does it do a basic subset of full text search, and does it do it well and quickly? Absolutely. So in exchange, if you don't need those features, what do you gain? Well, if you've worked with Elasticsearch, you've probably had some fun with, what do I do? Something updated in the main database, I've got to sync it to Elasticsearch, and those things can get out of sync. It's always a little bit of a pain. This eliminates that entirely. So what about document storage? Traditionally, maybe you'd use a NoSQL engine for this. Well, Postgres has JSON. JSONB lets you have indexed JavaScript searches, even XML storage. Works great. The last one is really, really crazy. Most people, if you say store files in the database, they'll think you're crazy, and most of the time they're right. But for very low volume, very low number of files, and small size of files, it actually can work very well because it eliminates a kind of thing. If you only have 30, 500K files, and that means either I have to, back up the file system, or I have to set up, S3 account, which, albeit it isn't hard, but it's an external dependency. Consider just storing it directly in Postgres. So what's another thing that we've learned from the big players and industry best practices? So microservices is one, or SOA is the, it kind of got rebranded. Now it's smaller services. Let's talk about some of the really good things that they give us. So the best thing, or one of the best things, is less communication overhead between developers when they're working on different parts of the system. If there's one part of the system that absolutely doesn't need to touch the other ones, and you can avoid having your developers have to communicate so much and have merge conflicts, all that sort of stuff, that's a win. It lets you scale parts of the system independently. It relaxes the coupling on language and framework features and versions. And that can actually be a big deal with a Rails monolith. That's one of the very difficult things when you get a very large monolith, is you end up dragging all these dependencies that you can't just upgrade one thing. You have to upgrade the whole world at once. That can be really hard. So that's a win for using a microservices. Your service could be implemented faster. Maybe you just have one endpoint that's really important, and you implement it in Go. You might be able to iterate faster. You're running your entire test suite is going to be faster because there's less to test. Presumably, you can upgrade those dependencies quicker. You might even go the Amazon route and be able to release this service to third parties. Remember, that's actually what AWS came out of. It was internal Amazon tooling to start. Now, what about the bad? So complexity will be preserved. In many cases, it's only moved around. So we've removed some dependencies, yes, but we've also just hidden them. The dependencies and the coupling now exist between services instead of more explicitly in the code. So if you're in a statically typed language and say you have some fields that are misnamed, they don't match up, well, you compile it, the compiler gives you an error, you fix it, you're done. If you have a Rails monolith, well, we're good Rails Ruby developers, we're going to write tests, right? So we run our test suite and we find it. If it's in another service, hopefully you find it before production. Maybe you have some sort of testing in place. Maybe you're mocking out that external service and you don't find it. Maybe you've used VCR, so you're recording a previously good response. What's worse than a single point of failure? Well, multiple single points of failure. Hard to imagine, right? So oftentimes, when you do a service, for your whole system to be up, all the services have to work. Well, now you have multiple places that each individually can fail. We kind of already alluded, testing becomes more difficult. Deployment becomes much more interesting. And there's entire industries built on helping remove the pain of deployment. As an aside, removing the pain of deployment actually is a good business. It kind of is an interesting thought that Heroku built a $1 billion business out of how hard Rails was to deploy. I mean, that's kind of scary when you think about it. If you have multiple data stores, and in service-oriented architecture, it's generally considered best practice that each service has its own isolated data store. Well, you can say goodbye to referential integrity. Your service should give you improved performance, and generally, since it's horizontally scalable, it will give you increased throughput. But latency becomes harder to manage. If to render a web page, instead of just hitting a database that's real nearby your server a few times, you actually have to make several HTTP service requests. It's quite possible that you may have a hard ceiling on what your latency minimums are. And that can be tough. Monitoring becomes a lot more difficult. In the old days of just deploying a Rails app with Capistrano, and you just SSH into the server, if I want to monitor it, if I want to see what happened in the logs, I tail log/production.log. Well, if a single request actually touches 5 different servers, just following that request along becomes a big problem, which then again, we have whole industries building up on how do you do your log aggregation. It's great that those solutions are there, but if you can avoid the problem entirely, it might be worth it. Security architecture, that's another really fun one. This service, how does it decide if, when you're sending a get my personal information request to the user service, how do you know if that's authorized or not? Well, do you check, security at the border? Do you have to pass some sort of authorization token around? They're all solvable problems, of course, but they're all things that you don't have to think about under the old school architecture. So here are some recommendations. Basically, it boils down to microservices are great when you need it for people or you need it for performance. So if you have a lot of people and it's going to help you organize them together, so it's going to map more to the structure of your teams, and it's going to help you not get in each other's way, microservices can be a good idea. For performance, it can be necessary when your monolith can't handle the performance that is required. So bad situations, if it's a small team where everybody works on everything, it's probably not going to help you. It's definitely not going to help you in the people front. It may help you in the performance front. It feels too big. That's kind of a case of the grass is always greener. I've worked on monoliths, and it's really painful. I've worked on microservice stuff, and that's really painful too. It's all painful once you get above a certain scale. So, and lastly, of course, the bad reason is I want to put microservices on my resume. So, in conclusion, we want to minimize the types of things. That's most important. Then we want to minimize the number of things. We want to look carefully at the costs of new abstractions, new services, clouds, whatever type of technique, library, framework, especially these web scale things that Facebook says, this works great for us. Well, we're not Facebook in general, so maybe React, yeah, that works great for us. But maybe scaling techniques for 100,000 servers, maybe they don't when we have 3. Distributed systems are really complex. I mean, like we talked about CAP earlier, if you want to dive into that stuff and look at all the really terrible failure conditions that there can be with distributed systems, well, you can spend quite a while reading about that. Complexity is totally the enemy of correctness. Anything you can do to simplify things is likely to help it be correct. Then as a general rule for we're not web scale, if you can fit on a single server, especially for the database and for the foreseeable future, if you're expecting that hockey stick to happen any minute now, maybe you want to go a different direction, but if you're in a domain that a hockey stick isn't going to happen, you're just going to have nice, linear growth, it's going to fit on a single server, it's probably best to do so. So the slides are on GitHub, and thank you.